Does your AV receiver have sufficient preamp outputs to properly drive external amplification? That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasello with Audioholics. As you guys know, I'm very measurement intensive when it comes to checking out performance of amplifiers, preamplifiers, and AV receivers. And about a week ago, Youthman asked me a question. He goes, hey, what's the sufficient preamp output level drive of an AV receiver to make sure that when you're adding external amplification, you're going to have a good match? I've spoken about the voltages that I like to see from preamp outputs in various videos, but I never did a dedicated video on this topic. So I want to do that here so you guys have this as a reference going forward. Now, I could give you the quick answer. I could give you the fish if you're hungry, but I also would like to teach you how to fish so you never go hungry. So if you don't want to watch this whole video, you just want the quick and dirty answer. For most consumer audio products with an amplifier gain of 29 dB, you want at least 2 volts RMS clean from your preamp output unbalanced, 4 volts RMS balanced to drive most amplifiers to full gain. But I want to show you why that is and how to calculate exactly how much preamp output voltage you need depending on the amplifier you're choosing so you can make better informed decisions. So I put together this slide presentation. There is going to be a little bit of math involved. It's not that hard. It's just basic log functions with a calculator. But this is going to give you the tools you need. So when you're shopping, you know exactly if this preamp and that power amp are going to go well together and you're going to get a good match and you're going to get the very best noise and distortion performance. So let me share my screen here with you guys. How much preamplifier voltage for external power amplifier? So we have a 3-step procedure on figuring this out. But before I even get into that, if you do have an AV receiver, it's important to note you need to have one that has preamp outputs on it. So here's an example of a back panel of an AV receiver. You can see the preamp outputs are for the front, center, surrounds, surround back, subwoofers. Some of the lower end receivers don't have preamp outputs. You can't use those with external amplification. Some of them have them just for the front preamp outputs, and some of them have it for all the channels. So you have to make sure that you're using an AV receiver that has preamp outputs on it. So step one is you have to calculate the preamp voltage for the power amplifier. You need to first know how much voltage that amplifier is going to deliver to the load. So manufacturers won't tell you the voltage, they'll tell you the power. They'll say this amplifier is 100 watts a channel at 8 ohms. So in order to calculate the voltage RMS of that amplifier, you need to do the square root of the power times resistance. So in this case, you got a 100-watt amplifier that's at 8 ohms. 100 times 8, take the square root of that, it's 28.2 volts RMS. So that's step one. Step two is we have to look up the voltage gain spec on the manufacturer's website. They usually call it just gain or AV, and they usually give it to you in dBs. So in this case, we're talking about an amplifier, the same 100-watt amplifier. The gain of it is 29 dB. We can't use a dB figure to do the calculation for input sensitivity. We have to convert that to a unitless figure. And in order to do that, you take the absolute value of the gain, you take the log, the anti-log of the gain that they give you, divide that by 20, and then you get your unitless number. So in this case, for an amplifier with a gain of 29 dB, you take the A log, or 10 to the X, of 29 divided by 20, and you wind up with 28.2. So now step three, you have to calculate the input sensitivity by dividing steps 1 by step 2. Let me first define what input sensitivity is. Input sensitivity, by definition, is the voltage that is required for that amplifier to reach max unclipped power. That's where that amplifier is going to give you the absolute maximum power, unclipped, full bandwidth, hopefully, if they give you an honest rating. Input sensitivity is an important spec, but it's often not spec the way you think. That's why I want to talk a little bit about how you could calculate this stuff on your own. So in this case, we take step 1, divide by step 2. So you take the power times resistance, the square root of that, divide that by the absolute value of gain, and you wind up with a 100-watt amplifier with a 29 dB of gain. You wind up with, you need 1 volt RMS to drive that amplifier to its 100-watt rating. This is a THX standard. And I want to get a little bit into that, why that's so important, especially in consumer audio. So if you look at the way THX does their standard for preamplifier and amplifier voltages, a THX certified amplifier, the unbalanced gain would be 29 dB, the balance would be 23 dB. There's a 6 dB difference. And then for the preamp, it's the opposite. The unbalanced outputs, the RCA outputs would be 23 dB gain, and the balance will be 29 dB gain. They do this for compatibility. And not all products that are THX certified are going to have this, but a lot of them do. So if you look at a lot of the Denon and Marantz and even the Yamahas, Onkyo, for example, they follow this kind of gain structure, and you see a 6 dB difference between unbalanced and balanced from those connections. There are cases where you don't see that. For example, when I reviewed the Anthem STR, the gain was the same from the preamp output, whether it was unbalanced or balanced, but you did get double the voltage capability of the balance because now you have a balanced output. I found that interesting. So it's really important to know what the gain structures are, what the maximum output voltages are for the preamp, and the sensitivity and the gain of the amplifier, just to make sure you get a good match. But this is a good reference. And in most cases in consumer audio, you're going to find this kind of signal topology. So what are the results? The input sensitivity calculation gives you the minimum voltage your preamp needs to output to achieve maximum unclipped rated power from your connecting amplifier. So in this case, a preamplifier, we need to drive 1 volt RMS unclipped to a 100-watt rated amplifier with a gain of 29 dB. We already discussed that. What happens now when you have a more powerful amplifier? So assuming the gain is held constant and it's 29 dB, every time you double the amplifier power, you need the square root of 2 times more voltage, or plus 3 dB more voltage. And that's just a rule of thumb here based on math. So in a case where you have a 400-watt amplifier with a gain of 29 dB, you need a preamp output that is clean to 2 volts RMS. So I put together this table. I just found this interesting. I was looking up various manufacturers and how they spec their amplifiers. And I discovered something by accident. I discovered that the input sensitivity specs that a lot of these manufacturers give you aren't always for max power of these amplifiers. That really shocked me because it was confusing. And the first example I want to go over with you is the Emotiva's XPA Gen 3. So their amplifier is rated at 300 watts at 8 ohms. If you look at the spec on their website, they say the input sensitivity is 1.5 volts RMS with a gain of 29 dB. When I did the calculation in watts based on that input sensitivity, I didn't get the 300 watts. I got 223 watts. So then I reverse engineered. I used the gain, I used the power, and I calculated the input sensitivity by doing what I was telling you, step 1 divided by step 2, the power times the square root divided by the absolute value of gain. And I calculated you needed 1.74 volts RMS in order for that amplifier to reach 300 watts at 8 ohms. I reached out to Emotiva and they said, yeah, there's a mistake on their website. They're actually going to correct it. I think they said their input sensitivity is more like 1.71 volts RMS. When you're talking to the hundredths of, to the right of the decimal point, you're splitting hairs here. But the bottom line is, in this case, their input sensitivity spec was not giving you full power. Another really interesting case is I looked at a high-end company called Audioflight. They're an Italian amplifier company. Love this brand. I've heard they're integrated many times. It just sounds, their stuff sounds beautiful. It's beautifully crafted. It's not cheap. So if you look at their flagship monoblock amplifier, it's a 650-watt amplifier with a gain structure of 29 dB. They spec the input sensitivity of 1.41 volts. And when I went and calculated that out, that was for 200 watts. That was not for its full power. In order to reach full power of that amplifier, you need 2.56 volts RMS. Interestingly enough, when I looked at their other products on their website, their input sensitivity and gain structures matched for the power that they were speccing. This was the only amplifier that I saw a discrepancy in how they rated their input sensitivity. So again, it's always important to take, I usually find the gains are correct, but the input sensitivities don't always give you maximum voltage or minimum voltage to get maximum power. So in the case with Parasound, this is another interesting case. I look at the JC5 and the input sensitivity is 1 volt RMS. When I calculated that out based on a gain of 29 dB, it only gave me 100 watts. And interestingly, when you look at how they are speccing it on their website, here's the amplifier right here, and you go to the specs, they actually show you it's a 400 watt rated amplifier. But when you look at the input sensitivity, they're telling you it's at 28.28 volts at 8 ohms. That's basically telling you that that's at 100 watts. So that's a different definition to input sensitivity, because like I said, input sensitivity usually implies the minimum voltage to get maximum power of that amplifier, but at least they tell you it's not maximum power. So again, it's important to know the gain. It's important to know the wattage. You could calculate it out, and I calculated you needed just a little over 2 volts RMS in order for that amplifier to be driven at 400 watts full power at 8 ohms. Anthem, I looked at the Anthem products, the MCA 525 Gen 2, rated at 225 watts with a 29 dB gain, input sensitivity of 1.5 volts. That actually came out to exactly what I expected when I did the calculations. I got like 1.51 volts to get 225 watts, close enough. So they were giving you the actual spec for input sensitivity for max power of that amplifier. Now, there are amplifiers like the NAD M23, which you guys know I reviewed and loved. It's the best measuring amplifier to date. It's used as the purified Class D module. They have 3 different gain structures. So they have a high gain, medium gain, and low gain. And they could see, they show you the different voltage gains of those amplifiers in those settings. And they give you corresponding input sensitivity. And when you calculate it all out, you get exactly around 200 watts like they expect. And if you look at the input sensitivity based on the different gain structures, and it varies anywhere from 1.39 volts to 4.49 or 4.5 volts. Now, if you're using an AVR and you have clean output to 2.5, 3 volts, or even 4 volts, you can use the medium setting. I would not use the low setting on an AVR. I would use the low setting if you have a dedicated preamp that has more drive. The advantage of using the low gain setting is you get better SNR performance, signal to noise ratio. The idea here is you want to have most of your voltage gain at the preamp section, and then the power amp should be your current drive. So it's driving the power to the speaker. Anytime you could do that, you can have more voltage gain at the preamp and then send that signal to the power amp and just use the power amp for current gain. You're going to get better SNR performance usually. So I like that NAD gives you that option for different gain settings. Benchmark Media Systems does the same thing. They have different gain settings, and they're even compatible with studio grade voltage levels, which are higher than consumer audio. Very cool when companies give you that flexibility. And then I wanted to show you a Storm Audio 200 watt rated amplifier with a gain of 26 dB. They don't give you the input sensitivity, so I had to calculate it. Like I said, doing the formula, I took the 200 watts times 8 ohms, square root of that. Then I did the absolute value anti-log of 26 dB, and I came up with you need 2 volts RMS in order to drive that amplifier to max power. Now, in case with Trinov, the Altitude 8, this is a very high-end amplifier, just like the Storm. They have a much lower voltage gain on the amplifier because I was telling you, they're trying to preserve the best SNR. You need almost 7 volts RMS to drive their amplifier to this rated 225 watts. You're not going to be driving this amplifier with an AV receiver. In fact, I don't know anybody that would pair such an expensive, high density, high channel count amplifier like that with an AVR. You're usually going to pair it with an Altitude 16 or 32 processor from Trinov, or maybe a Storm Audio processor, or maybe even the Marantz AV10. Those processors have lots of output drive from their preamp outputs, and they're much more compatible with an amplifier like this. So it's important, again, it's important to know how much voltage you need for that amplifier to reach max power, because you don't want to be in a scenario like I was years ago when I set up a system for an uncle of mine that likes to have these big Colombian parties. I set him up with a midline Yamaha receiver with an Emotiva amplifier. And when we were cranking it up at the party, the receiver was shutting off, not the amplifier. The problem was that AVR did not have enough voltage drive. It couldn't even do more than 1.5 volts, and the Emotiva needed over 2 volts to reach full power. So as he was cranking the volume up, even though the amplifiers weren't being used, they were unloaded, those amplifiers still had voltage on them. So they were still clipping, and the internal circuitry of the Yamaha was protecting itself and shutting it off. So that was a case where we did not have enough voltage drive for the amplifier to reach max power, and that was detrimental. And I had to go and make some changes in the system to compensate. So I want to show you just some preamp output ratings as a reference here. Years ago, I did a review of a Yamaha RX-A 860. This was like kind of mid-priced AVR. It was a 7-channel AVR. What I found on this receiver was the amplifier section on it was awesome. It was better than most amplifier sections in receivers at twice the price. But the preamp section was the weak sauce. In fact, I think I said in the review they should have just done away with the preamp outputs, because someone buying a receiver at this price is probably not going to use external amplification. And then if they do, they're going to do an injustice to that amplifier. And the reason why I say that is, if you look at the FFT on the preamp output at 1 volt RMS, that looks pretty good from the preamp output. The second harmonic is 100 dB below the fundamental. But when you drive it to its near 1.6 volt spec, look at that distortion just go through the roof. I mean, we're looking at third order harmonic only at minus 50 dB below the fundamental. That's just nasty. I don't like that. And in fact, in that case, if you start cranking a receiver like that up with a really good amplifier, you're now limited to the distortion of the preamp output, not the distortion of the actual power amplifier driving it. And you can see I highlighted here. In this case, Yamaha even gives you the spec that it only drives 1.6 volts RMS onto the output, but that's at really bad distortion because that amplifier section itself is clipping. I think the amplifier was clipping at maybe a volt, 1.2 volts. So anything above that is hard clipping, and that noise and distortion from that amplifier was ingressing back into the pre-outputs, polluting it and giving you this nasty distortion. So that was an example where that preamp did not have sufficient drive to drive an external power amplifier. But Yamaha's fixed that. Over the years, I've been a stickler with them and other manufacturers. A lot of their older receivers would clip at like 1.5 volts. They just did not have the good preamp output drive for that. They've eventually changed that, and now most of the Yamaha products that I've been measuring as of late will give you 4 volts RMS output out of the preamp outputs. In fact, all of the Denon and Marantz, Onkyo, Anthem, they give you 4 volts RMS, and I really have to say kudos, thumbs up to that. That's great because that'll allow you to use a multitude of amplifiers without running out of preamplifier voltage, so you can get those amplifiers to work at their full potential. So if you look at the Yamaha RX-A 6A, they spec the preamp out at 2 volts unbalanced, 4 volts RMS balanced. They actually have XLR outputs for the front outputs, but I actually measured 4 volts unbalanced, 8 volts balanced. So what I want the takeaway here is when you look at the specs on the manufacturer's website or on their owner's manual, unless they tell you the preamp output is maximum voltage of what they could give you, they typically aren't giving you max voltage. They're giving you a reference voltage based on whatever signal to noise ratio and distortion spec that they tested, that they ran their configuration for when they did that test. Same thing with the Marantz AV10. If you look at the spec of the AV10, they say the unbalance is 1.2 volts RMS and the balance is 2.4 volts RMS. I got way more than that. When I bench tested this, I got 6.5 volts unbalanced, unclipped, 13 volts balanced unclipped. So that's a big disparity there between their spec and what's actually the max capability of the preamp output. So again, it really pays. When in doubt, if it doesn't say max voltage RMS, check and see if we did a review of that product, because I always measure the preamp outputs of receivers and processors and give you this information so you can make these calculations and figure out what amplifier goes best in your system. So looking up the Marantz SR8015, it's the same thing. They spec it at 1.2 volts. I measured 4 volts RMS. The Anthem, the MRX 740 and 1140, they spec it at 5.2 volts. I measured 5.5. So kudos to them. They gave you an honest spec. But I wanted to show you something interesting of what I found over the years on preamp outputs on receivers. So I'm comparing here an SR8012 to an SR8015 from Marantz. You could see at 2 volts RMS output, there's a third order dominant distortion product, but it's 80 dB below the fundamental. And I noticed when I drove the voltage down to like a volt, the distortion was much lower. And I'm like, what's going on here? Well, it wasn't until years later that I figured out that these amplifiers, when they clip, even though they're unloaded, a lot of them will ingress that noise back into the preamp output circuit. So I asked Marantz, can you guys offer a preamp disconnect and put a buffer circuit in between the amplifier and the preamp to avoid that issue? Sure enough, they listened. And I love when manufacturers listen. And you look at the distortion of the SR8012 versus the SR8015 under the exact same test conditions. Look at the difference here. The 8015 has 20 dB better FFT at the third order harmonic. It's down 100 dB below the fundamental. Look at that difference there. Now, is this audible? Probably not, because minus 80 is good enough. But if it's like minus 40 or 50, that's definitely audible. That's not good. But in this case, Marantz did a great job in giving you good preamp outputs, and they just made them that much better. And then we look at the Marantz AV10 preamp outputs. What I wanted to show you here is, this is an interesting graph. So I measured the voltage RMS output versus distortion in a percentage on the left column of the vertical axis. And on the right column, I did it to dB for SINED, for all you SINED fans out there. And you can see this preamp output gives you the best SINED performance between 2 to 4 volts RMS. So even though it puts out 6 volts RMS out of the unbalanced, you get the best SNR under 4 volts. But we're still splitting hairs, because even out to 6 volts, we're at 90 dB SINED, which is really low distortion. Very good number there. So if you look at this graph, you can see the SINED performance is excellent all the way out to almost 6 volts RMS. We're talking 90 dB SINED at 6 volts RMS, which is a fraction of distortion. If you want to convert that to a percentage, it's like 0.002%. That's inaudible. This preamp has plenty of drive. And then you look at the XLR version of it as well, and you get double the voltage. You get plus 6 dB. Same kind of thing. The SINED performance is great all the way out to almost 10 volts RMS. So a preamp like this will drive any amplifier on the market, no problem. Even the low gain amplifiers. A preamp output of the Marantz of this caliber just gives you more flexibility in choosing lower gain amplifiers to give you even better SNR performance. So what's the bottom line on preamp output voltage? Bottom line on the specs is amplifier input sensitivity ratings aren't always accurate. Unless they tell you that it corresponds to the maximum power that that amplifier can deliver, you could almost always assume that they're not giving you that spec as it's defined in the textbook. When in doubt, you can calculate. I gave you the tools by dividing those two equations. You could calculate the input sensitivity on your own. I gave you the tools to fish, so please do that. And preamp output specs aren't always maximum, as I showed you with that example with the Marantz. So it's really important, if you don't know that information, to look up our reviews to see if we measured it or if somebody else measured it on another website. Really important to know that information. When in doubt, check our measurements or ask the manufacturer if it's even possible. So what's the bottom line on preamp output voltage? You need at least 2 volts RMS unbalanced, 4 volts balanced for THX type amplifier gain structures, which is what you're going to see in most consumer audio. The only exception I saw in the mainstream audio was Anthem, where they gave you the same preamp gain structure, but they did give you double the voltage for balanced. Low gain amplifiers require higher preamp output levels, but usually offer better SNR performance. So just as a reference, the unbalanced outputs on a DAC are calibrated to 2 volts RMS at 0 dB FS. 0 dB FS is digital full scale. And you want the amplifier's input sensitivity between 1.6 to 2 volts RMS for best SNR in those scenarios. For balanced outputs on a DAC, they're calibrated to 4 volts RMS at 0 dB FS digital full scale. And in that case, you want an amplifier input sensitivity between 3.2 to 4 volts RMS. Now, studio balanced outputs are usually calibrated to a much higher output between plus 22 to plus 24 dBu at 0 dB FS. We did an extensive live stream with Benchmark Media Systems on that topic. I'll link it up in the cards. I really suggest you watch that video on amplifier gain structure and gain matching between preamp, DAC, power amp. It's very useful if you want to maximize signal to noise ratio, lowest distortion, lowest noise floor. You just want to make sure you have good matching like I was discussing here. So guys, I hope you liked this video. Please hit the thumb up, hit subscribe. Right now, we are running an RBH Subwoofer Giveaway sponsored by Dream Media. I'll put the links down below. It's your chance to win a 12-inch, 800-watt powered subwoofer from RBH. It's a $1,500 value. We're running that for the new year all the way to January 31st. So if you're in the United States, please enter to win. Don't forget about our Patreon channel at patreon.com/audioholics. We appreciate your support. You get direct access to me if you want to suggest video topics. And until next time, my friends, keep listening.